Welcome to this introductory probability lesson. Here we'll take a look at 5 problems to show you the very basic beginnings of the study of probability. Hit pause and read this question to yourself. Now let's take a look at this question. When you're computing the probability of an event happening, that's a measurement of its likelihood. And this measurement is always a number between 0 and 1, where 0 represents an impossible event, something that can't happen, and 1 represents a certain event, one that will absolutely happen. Most events are neither impossible nor certain, and they're somewhere in between. And it's that window between 0 and 1 that we study in a probability class. Taking a look at this problem, and most problems, you can compute the probability using what we call the favorable over total fraction. I'll explain what those words mean. First of all, favorable sounds positive. It doesn't necessarily mean that. It just means favorable to the conditions of the problem. For example, in this problem, we're being asked about the likelihood of getting a green marble out of a bag. Well, favorable refers to the number of chances of us getting that green marble. It doesn't mean that the green marble is better than the other colors. It's not a value judgment. Well, that being said, let's take a look here at what we mean by total first. The total refers to the total of all the outcomes. In this experiment, we got a red marble 11 times, a green marble 5 times, and a blue marble 14 times. I added those up, and that adds up to a total of 30 experiments. So out of those 30 experiments, you can see that there were variations in green, red, and blue. But 30 is nonetheless the total number of experiments that we've tried. In other words, the number of times we pulled a marble out of the bag. Favorable refers to the number of instances that correlate to the question being asked. Since we're being asked for the probability of a green marble, then we need to use 5 as our favorable number here because there were 5 times that we got a green marble out of the bag. The last thing that we want to do on this problem is notice what format the answer is being requested. We're being asked for a fraction, which we currently have 5 out of 30, but we're being asked for it in simplest form. And even though the fraction can be started out as 5 over 30, because after all, we drew a marble 30 times and 5 of them it was green. So we can say that 5 out of 30 is the probability of getting a green marble. But since 5 out of 30 is reducible to 1/6, we should always put our answers in simplest form when being asked to do so. Here's a second problem. Hit pause and study it carefully, and then hit play when you're ready to resume. Okay, now that you've read the problem, let's take a look at the same concept here of favorable over total. That's how we can compute the probability of our particular event. Well, you'll notice in this problem that even though they list 9th and 10th grade students, the question is only about the probability that a chosen 10th grader will play the guitar. So sometimes in probability problems, you have to ignore things that aren't relevant. The 9th graders simply aren't relevant to any of the calculations here, based on the way the question is phrased. So focusing on the 10th graders, let's take a look at favorable over total. First, the total refers to the total number of 10th graders. I added that up, and I got 29. And out of these 29 10th graders, how many of them fall into the so-called favorable category? Well, the problem is being asked about the chance that this random 10th grader will play the guitar. So the guitar 10th graders are the favorable ones, and in this case there are 4 of those. You don't necessarily have to think of it as favorable over total. You can just think of it at a more basic level. Look at the fraction at the bottom of the screen as I say this. There's 29 10th graders and 4 of them play the guitar. So if we pick a 10th grader at random, there's a 4 out of 29 chance they'll play the guitar. Now, if they're asking for a fraction, I'd be done with this question. But they weren't. They were asking for our answer as a percent to the nearest whole number. So what you should do at this point is reach for a calculator, type 4 divided by 29, and it'll give you a decimal. That's not a percent, that's a decimal. To convert that to a percent, we can move the decimal 2 spaces over, an old trick from elementary school, and that is a valid answer except for the fact that they're asking it to the nearest whole number. So 13.79 rounded to the nearest whole number is of course 14, and therefore 14% is the final answer to this question. Here's our third out of 5 problems. Hit pause and take your time to read. Okay, now that you've read the problem, let's once again try to compute our probability as favorable over total. The total refers to all the customers from that particular week. I added all those up and found out there were 140 customers. Now let's take a look at what's favorable. What makes this problem a little different is that the question is not asking us specifically about cash or specifically about debit card users or specifically about the credit card users, the 3 main ways to pay for something. If you look at the bottom of the word problem, it says they're asking for the probability that something other than a credit card will be used by the next customer. Well, something other than a credit card, look at the purple text near the top of the problem, that could either mean cash or debit. So when they said something other than a credit card, the so-called favorable would be the other 2 forms of payment. I added 83 plus 16 to represent the other 2 forms of payment, and I got 99. So 99 is my favorable number here. Now, if they were asking for a fraction, I'd be done, because that is not reducible. But they're not. They're asking for a decimal to the nearest hundredth. You may recall the nearest hundredth means 2 decimal places. So reaching for a calculator and typing in that fraction, 99 divided by 140, will give you approximately this decimal. But I'm not done because they asked me to round to the nearest hundredth, in other words, 2 decimal places. So that would round up, using the 5 or higher rule for rounding, that would round up to 0.71. If they asked me for a percentage, I would say 71%, but because they asked me for a decimal, I'm going to leave it in that format. Here's our 4th problem. Go ahead and hit pause and read carefully. Okay, now that you've carefully read the problem, let's once again try to compute the probability by using favorable over total. The total, of course, would be the total number of visitors to this website. I added up 108 plus 190 plus 13, and I got 311. That's the total number of visitors to this website. But what's our favorable number? Well, what makes favorable strange here, read the purple text near the bottom of the problem. It says we want to know the chance of no more than 1 costume was purchased by a particular customer. Well, let's analyze what that means. No more than 1 means not 2 or higher. But to think of it another way, no more than 1 could mean none or 1, couldn't it? So when they say the probability that no more than 1 customer, that they purchase no more than one costume. That includes, look at the purple in the middle, that includes both 108 visitors or 190. Imagine it as if they had said, what is the chance that a visitor bought either no costume or exactly one? It would really be the same question. So to get my favorable, I added 108 plus 190. That gave me a 298 favorable. This particular problem is asking for a percent to the nearest whole number. So I reached for a calculator, did the division problem, 298 divided by 311, and I got this decimal. Moving the decimal over one space would give me 95.8%, which rounds up to 96% by the rounding rule. And that's the answer to this question. Before we go on to our last problem, let's analyze the answer in terms of whether it makes sense or not. Look at the data in the bullet points in the middle of the problem. It looks like the majority of customers or visitors either bought no costume or exactly one. Very few people purchased two or more, which is the same as saying more than one. There were only 13 of those. So it seems logical to me that there would be a very high likelihood that someone bought no more than one, because the people who did buy more than one were only 13 out of over 300. So this very high probability, close to 100%, seems to be fitting for this particular problem. Here's our last problem. Go ahead and hit pause and read carefully. Now that you've read the question, let's once again compute our probability by calculating favorable over total. The total is the number of times a random candy was taken out of this bag, and I added those up, and it turns out there were 48 random candy experiments where one candy was taken from the bag. By the way, just as a side note, this does not mean that there were 48 pieces of candy in the bag. There could have been 1,000 pieces. What this 48 represents is how many times one piece of candy was pulled from the bag. It's 48 experiments, or the total number of trials. Now for the favorable number, notice in purple they're asking the probability that either a lemon or a peach candy was pulled from the bag as our next draw. Well, based on past experience and looking at the bulleted data in purple, there were 14 lemons and 22 peaches, which adds up to 36 total of those two. So when they say the probability of either a lemon or a peach, we should add those two together as our favorable. And that fraction represents our probability. I wouldn't consider it a final answer though, because even though they are asking for a fraction, they're asking for it in simplest form. 36/48 is a fraction, but it's reducible. Turns out, and you may just know this, those two numbers are divisible by 12. And when I divided the top and bottom by 12, it shows that this fraction reduces to 3/4. What that means is, and that is the final answer to this problem, by the way, what that means is there's a 3/4 chance that my next candy, that if I draw one out of the bag, will either be lemon or peach. And that completes this problem. And that also completes this video. Thank you so much for watching.